Welcome to the next video. In this video, I will be showing you one example of first come first serve where this context switch time is also added. It is called context switch overhead. Okay. Oh, let me clear this table so that I can feel you in front of you so that you can understand it in much more better way. Okay. So this let me clear. Okay, this is done now. Okay. So let's say this context switch time is 2 unit. Okay. And this is the process number and the corresponding arrival time and burst time. Okay, like this. Alright. So what will happen at time t equal to 0, your CPU will start. Okay, the context switch time is 2 unit. Till the time 2, it will be switching the context. Okay, at time t equal to 2, this process P1 can be scheduled. Okay, if this is a ready queue, at by the time t equal to 2 has arrived, what are the processes in the queue? That is P1, okay, because it is 0, then P2 because it is 1, then P3. Alright. So at time equal to 2, your CPU has this P1 to be scheduled. Okay, let's schedule this P1. So here this P1 is scheduled. What is the burst time? That is 5. 5 plus 2 is 7. Up to 7, this P1 will be executed. Now, by this time, P4 has also arrived. Now, your CPU will see that now P1 is already done. So, your CPU has to do this P2 now. So before your CPU schedules P2, it will have to go for one another context switch. Okay, let's say this is again context switch. So what is the duration of this context switch? That is 2 units. So at 9, this context switch will be done. Okay, then P2 is scheduled. When this P2 will be finished at 9 plus this burst time, 9 plus 6, 12. Okay, then P3 has to be scheduled. Okay, but before that, there has to be a context switch for 2 unit time. So at 14, this P3 can be scheduled. So what will be the completion time of P3? That is 14 plus 8, how much? 22. Now this P4 has to be scheduled, but before that one may another context switch. So this will be at 24. This because this is 2 units, 22 plus 2, that is 24. At 24, this P4 can be scheduled, but this burst time is 6. So 24 plus 6, 30. This P4 will be finished at time t equal to 30. Alright. Now you seeing this Gantt chart, let's fill the table. What is the completion time of process P1? That is this much, that is 7. What is the completion time of process P2? 12. Completion time of process P3, that is 22. Completion time of P4, that is 30. Alright. So turnaround time is completion time minus arrival time is turnaround time, that I have already shown you in previous examples. Okay. So that formula was turnaround time equal to completion time minus arrival time. So fine. 7 minus 0, that is 7. 12 minus 1, that is 11. 22 minus 2, that is how much? 20. 30 minus 3, that is 27. Alright. Fine. What is the wait time? Wait time will be, let me give you the formula again. Turnaround time is wait time plus burst time. Okay, that I have already explained you. So what is the wait time? Wait time is turnaround time minus burst time. So turnaround time minus burst time is the wait time. So 7 minus 5, that is 2. 11 minus 3, how much? That is 8. So 12 minus 8 is how much? 12. Sorry, 20 minus 8 is 12. 27 minus 6, that is how much? 19. Sorry, I made a calculation mistake. That is 27 minus 6 has to be 21. Alright. So now let's see the response time. What is the response time? When your process has arrived and when your process is scheduled for the first time, this duration is called response time. When the process P1 has arrived at time t equal to 0 and when it is scheduled for the first time, that is time t equal to 2. So response time is 2. Alright. Coming to P2. P2 has arrived at time t equal to 1 and if you see P2 is scheduled for the first time at time t equal to 9. So 9 minus 1, that is how much? 8. So P3. P3 has arrived at 2 and scheduled at 14. 14 minus 2, that is 12. Alright. P4 arrived at time t equal to 3, scheduled for the first time at 24. So 24 minus 3, that is 21. This is the response time. So now let's see other things as well. Okay. So what is the schedule length? So if you calculate the schedule length, that will be that I have already told you, max of completion time across all the processes minus minimum of arrival time across all the processes. So if I go back to my previous video, then you can see the example. Max of all the processes, okay. So max of completion time of all the processes and minimum of arrival time across all the processes. So if you come down, so what is the maximum completion time? That is 30. 30. Alright, let me see the color. And what is the minimum of all the arrival times? That is 0. Alright. So this is 0. That means your schedule length is 30. So how much time your CPU is idle during this 30 second? I mean this 30 unit of time. So your schedule starts at time t equal to 0, okay, because your first process is arriving at 0 and it is going up to time t equal to 30. So during this duration, what is the time your CPU was idle? So in this example also, your CPU was never idle, because at these times, even though you may feel these times your CPU was idle, but practically your CPU was not idle at that time. What your CPU was busy with? Your CPU was busy with the context switches, alright? But here, by saying CPU idle time, let's consider those time when your CPU was not working on any of these processes, okay? So such idle times are this and this, okay? So what is the total time? That is 8 unit, alright? So what is the CPU efficiency? So already we have seen this formula, schedule length minus idle time divided by schedule length. So this efficiency will be, well, how much? So what is the schedule length? That is 30. What is the idle time? That is 8, okay? So what is the schedule length? 30. So 22 by 30. Okay, let's calculate this. So that is 73.33%, something like this. All right. So the schedule length formula I have already explained you in the last video. So for all the processes, what is the maximum completion time, and across all the processes, what is the minimum arrival time? Okay, these are difference between these two. We have calculated the schedule length and we have calculated the CPU efficiency both. Let's calculate the throughput. So this is the number of processes. What is the number of processes here? That is 4. And your schedule length was how much? 30. So that is 2 by 15. So that is 0.13. So there can be questions like, for any process, let's say process 1, process 2, process 3, what is its turnaround time, what is its waiting time, what is its response time, and what is the completion time. Also the average turnaround time, average waiting time, average this response rate time. Okay, you will have to sum up all the turnaround time and you will have to divide that by the number of processes. Okay, similarly for waiting time, similar for response time. What is the maximum turnaround time across all the processes? What is the maximum wait time across all the processes? Such things. So if you see, once you prepare the Gantt chart and you prepare the table, you can answer all the possible questions. All right.